Hey everybody, Mr. Johnston here, and today in this video we're going to talk a little bit about particle diagrams. We want to know what particle diagrams are, how we use them, and we'll look at some examples of good and bad particle diagrams. I just want to mention real quick, sometimes I think of particle diagrams as sort of like nano vision goggles, like you're zooming in on things that are way too small to see. And then we're trying to represent what we might be able to see on that really, really small, zoomed in version of something related to atoms, molecules, particles. So first, particle diagrams are a way of representing atoms and molecules, which those atoms and molecules are way too small to see. And so we need a way of trying to show what's happening on that molecular level. Particle diagrams are really just conceptual tools with the intention of visually sharing information. And so particle diagrams are always trying to communicate something. They're a drawing, a diagram meant to communicate something about what's happening on the molecular level. Sometimes we take a little bit, particle diagrams should show proper ratios of atoms and molecules. So if we look at this diagram on the right, I see water is what's being represented here. And we're kind of like zoomed in on what the water looks like in this little tiny spot. And in this case, there's always one oxygen for every two hydrogens, and that's represented throughout the diagram. The other thing is sometimes particle diagrams do not attempt to show the actual shapes and sizes of the molecule. They're typically not drawn to scale. So in this case, water, it looks like circles, and it might be a pretty good approximation of what water is, but obviously we're taking some liberties there. Oxygen atoms are not really red, but we're coloring them red just to represent the difference between which part is oxygen and what part is hydrogen. Good particle diagrams, they should use simple shapes to represent individual particles. We use different shapes or different colors to represent different types of particles. Drawings have a reasonable number of particles. We don't want to overwhelm the viewer by showing 1,000,000 particles in our particle diagram. So having a reasonable number. Also, if you had only one or two, that might not be enough to communicate what you need to communicate. Spacing and arrangement of particles is indicating state of matter, and so it's not just random how you draw those particles. There is, purpose behind how you space things out to show if it's a solid, if it's a liquid, if it's a gas. Ratios are properly shown. As I mentioned, it could be like the ratios in an individual molecule, or if we're talking about a mixture, it could be the ratio is showing the percent of each thing in the mixture. And so those ratios are important. Also, good particle diagrams must include a label and or a key to show what is in the particles, or what is each thing represents. Bad particle diagrams, on the other hand, individual particles can't be identified. It might not show all of the individuals. The diagram is not done neatly. Shapes are not consistent. There might be too many or too few particles. Spacing of particles is maybe not obvious to show the state of matter. That's one thing about particle diagrams, is it should be obvious. And if you're not careful, sometimes things can be difficult to interpret. A bad particle diagram might not show or consider proper ratios. And then a bad diagram would also lack a key, and so make sure that you include those things. A couple other things just to mention real quick here is we can also show motion of particles in these diagrams. And sometimes we can show things like attraction between particles. We call those intermolecular forces, IMFs. We can also show bonding with a particle diagram. I do have a few examples here. So here's a couple of good examples of particle diagrams. I see the drawings are pretty neat. I see keys. I can see good spacing. There's not so many particles that it's overwhelming to look at. Things are labeled. And so those make a couple of good particle diagrams. Here's some examples of bad particle diagrams that we've seen. Somebody's trying to represent steel wool and they just draw a big squiggle. Well, I don't see individual particles there. And so that's not a very good way of representing things on the molecular or the particle level. This one, somebody's trying to show the rock granite, and they just drew a bunch of circles, but even the circles are not all the same shape. They're not all the same size. Some of the circles are not closed all the way. It looks like they were real sloppy and quick with their drawing and not careful. Also, the particle diagrams on the right side, neither of them include a key or a label. And so I want to be able to see what the individual particles are on those diagrams. Also, I just want to mention real quick that this is, there is some convention for color coding. You don't have to use this convention, but it's used throughout your textbook and in other chemistry resources. And so I did want to just mention this, that when you're showing atoms in a molecule, we can use circles to represent those atoms. And there are colors associated with each type of atom. And so, like, for example, black circles are always carbon atoms. Blue circles are always nitrogen atoms. Red is always oxygen. And so, again, as long as you include a label, then your particle diagrams can be different, but they do need to be labeled. In the next video, we'll talk about how to make particle diagrams.